Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about how to make boring company actually work, because majority of the people, even news channels at this point in time, yeah, that was a bad idea. So this is a different kind of experimental video from me. It's like take bad ideas and make them work as best possible. So before we dive deep into it, we have to understand how the heck this weird problem happened. It's like I used to be very angry at this, like how the heck Indian people, like I always was like, American people dumb, they fall for Hyperloop, and then my brother did that in Mumbai, and we burnt money, like a lot of money, like seriously painful amount of money, and then I was like, what the hell? And then I deep into it. How the heck educated, trained, professional people can fall for this? Then I realized there is a disease known as CWS, Celebrity Worship Syndrome. And I'm not joking, it's actually a disease. I did not even knew that. Like it's an actual disease. And it is real and it causes mindlessness, meaning common sense, you will like, gone. I'm not even joking. Like Elon Musk could come out and say things that even a kid like me who was watching National Geography construction shows were like, dude, what you are saying has been done for like freaking 1950s. It's an old thing, but like he says that and every news anchor is like, oh, we never thought of that. We were never so wise. It's like, bro, we have this. It's like Elon Musk literally came out. He said like, oh, tunnel construction is so outdated. It's like we don't build segments right where they are using it. Like, no, we do. We only do that for large scale project. If your tunnel diameter is more than, let's say, 12 meters or something like that, there is a very good chance the concrete blocks that is going to be consumed by the tunnel these things would be made on site. It's always done that way. Only for small tunnels like utility tunnels, we don't do that because it does not make sense, or in some scenarios where you do not have space control. Like we figured this part out in 1950s. It's like he's showing that people are like, oh god damn, he's so right. It's like, bro, we have sorted that puppy. And this is the celebrity version side. Like Elon says equals good. It's like he said it, that means it's good. I'm like, we have 150 years of metro system. 150, not 1 year, not 2 years, not 100 years, 150 years. The tube in Britain, it's more than 150 years old at this point in time. It's old. We figured out everything. That's why everybody builds metro. That's why Delhi has metro. That's why Bengaluru has metro. That's why Tokyo has metro. That we have figured this out. We have figured it out. It's like, given the constraint of reality, this is the best tool. Just because Elon Musk said it, just because everybody is like, suffering from CWS, does not mean that is untrue. It's like, dude, we know this is a factual data point. It works. It's a known technology. And tunnels are expensive. That is absolutely true. And they become exponentially more expensive the bigger the diameter. Basically, if you are making utility tunnel, it's expensive. When you are making like large diameter tunnels for multiple trains, it becomes exponentially expensive. Yes, that is absolutely true. But here's the remove the mechanical side of it. He's like focusing so much on mechanical side. Here's the that's not the limitation. Never ever in entirety of human construction we're like, oh, our mechanical tools are not bad. It's like the reason why tunnels are so expensive is because red tape, bureaucracy, environmental review, and many times even if you have a horsepower, you may not want to go that fast. Many times when we are building tunnels and we mess things up, generally we are going too fast. We have learned this the hard way. Of hundreds of years of digging tunnels, we learned it the hard way, that go slow. Even if you can go fast, go slow. Take your time. Take as many samples as you have to. And not to mention, things break. When you're talking about, like Elon Musk built kilometers of tunnel and people have hundreds of kilometers of tunnel experience, they're like, dude, we can go faster. We choose not to, because it's always better to like be cautious. Because again, if we mess it up, the TBM could be stuck there for years. It will cost billions of dollars to recover that. So we have learned this. Like, and everybody talks is like, oh, he's like using rocket technology. I'm like, that's a utility tunnel TBM. You can just buy it. It's like it's electric powered. All TBMs are electric powered. Nobody is stupid enough to put diesel generator there. We figured this out hundreds of years. It's like, that's why. I used to be very angry about that, but now I realize that CWS is apparently a thing, apparently is real, and does cause damage. My brothers. So let's start how the heck you're going to solve it. So first we come to tracks, because you have to understand why the heck we jump to tracks for hundreds of years. Well, reality is very simple. Nothing beats the rolling resistance of metal wheel on metal track. If you have very high grade steel and very high grade steel wheels rolling on each other, they are like butter. And I do not mean as a joke. You can actually pull a train. Single human can pull a train. And the reason, even if you're feeling resistance are generally because of the grease used in the bearings. If it's rolling a little bit, you can keep continuing. You will be surprised. And that's how early trams were built. They had 10, 20 people, and horse were used to pull. One horse. How the heck that happened? Rolling resistance of metal wheels on that. 2 or 4 wheels, you're going, man. You're going. 4 horsepower, you're going. How the heck that happened? That's the whole thing. Rolling resistance goes down. That's why we build a train in the first place. Energy is never free. Even if you're dumping it through electrically, it's never free. It has to come from somewhere. So fundamentally, it's always wise idea to not waste as much as possible. So that's the first thing. Then why the heck we do not use railway tracks? Again, when this tunnel was built, this is how muck is removed. And it's a common thing. Every tunnel boring machine generally has a railway track. Unless it's a very small one, then they may have a conveyor belt. But generally they have a train where muck fills up the, basic coaches, and then it's you pull it out. It's a common thing. So they have built it. Then why the heck they are not making train on it? Well, reality is the gauge, as in the distance between these two puppies are tight. They are what you call narrow gauge or meter gauge. They are not very big. So coaches would be very damadol. If you want to have a real world example, come to Kashmir of India, and you will have toy train. There are many places that have active toy train, passenger level. It's not a toy. It's it looks toy compared to broad gauge. So we cannot use small system. So what's the issue? Why can't we just make it bigger? Again, if the basically tunnel is capable of having this sort of width, track width, why don't we do that? Well, there is something known as turning. If you have to turn, if you make the track width large, the turning radius, basically the RPM of the wheel that is inside versus the RPM of the wheel that is on outside, it goes exponentially. And if you have ever noticed on the trains, be it small one, be it large one, they generally have coupled axle, meaning there is one axle and 2 wheels. It's one unit that is spinning. So there is a limit how much tolerance, RPM tolerance it has. So you cannot turn it as quickly as possible. So this small tunnel generally have much higher tire tolerance because again, it was designed with a car in the mind. So how do you enjoy track efficiency on turning efficiencies? Well, you have to go what we call independent wheel suspension, meaning there is no through rod. They are independent unit. Yes, it has been used in many systems, and yes, it was even tried in India, but unfortunately it was rejected. Not unfortunately, it did not suit us because we have to carry a lot more people. This is designed for speed. It's very efficient, a very low horsepower locomotive can drive these puppies up to hundreds of kilometers per hour, but we don't need speed that much, we need capacity. So this was not suited enough, but here is awesome. And again, it will bitch slap any 4 cars, car, sedan, SUV, it will bitch slap that. So it's a tested technology, we just have to port it to this side, and that will allow us to make tracks wider without having that issue. It's how the heck you turn it, or your turning radius becoming very gentle. You don't have to worry about it. You can turn as tightly as metal would allow. And again, these body has to behave like a one unit. Otherwise, then you're gonna have jump out. You cannot have independent suspension. They have to act like one rigid body with RPM independence. RPM is independent on this. And then you can have very tight tolerance without any issue. And you have to use locomotive. We cannot use what we call multiple drive units, basically EMUs. So basically, majority of metros are EMU. They collect power, they have their own motors, they have their own inverter driver system, and the driver cabin in the car, there's just a trigger mechanism. Basically, it controls how each inverters are behaving, nothing more than that. It does not have the locomotion. It's everything that is behind it actually has its own capacity of moving. Not every single bogies could have that, but majority of the time bogies are driven. That's good for large scale, but here it is not desirable because it will make the cost go up. So we have to keep the cost down. So we have to go back to the locomotive. Now, how will you drive the locomotive? If you have ever looked at any locomotive, you must have noticed they have giant induction motor, one small gear, one huge gear, and then one through shaft. Here's Dean. Thankfully, that part is already sorted. Cars have differential. We have already solved that part. So we have to use tracks, have independent floating RPM designs. Again, tell me which train it is. It's from Italy. That's what I'm telling you. It has that independent wheel system that will allow us to make wide tracks on very tight turns. That will solve one issue, and we have to use locomotive. We cannot have multiple drive units. Then we come to the locomotive. How the heck we gonna drive this puppy? Well, we have to use swappable LTO cells. Why LTO cells? It's basically brethren of lithium cells. They are inherently safe, meaning if you puncture them, nothing bad happens. If you cut them, nothing bad happens. Inherently, they are safe. If you set them on fire, they burn like wood. They do not add fire to it. Now, you have to understand, inside a tunnel, if an electric car catches on fire, which it will sooner or later, today or tomorrow, it will happen. It's one of those things there is a law, Murphy laws, it's gonna happen. It's oh, what happens if plane catches on fire? Trust me, people set planes on fire just to figure out what happens. We have learned it the hard way that anytime you are dealing with public infrastructure, figure out what's the worst case scenario and then test accordingly. So this is the best way to passively save it, where it's like, oh, electrical malfunction, should not set it, boom. And what happens when an electric vehicle catches on fire? Nothing. Fire brigade just pours water for upwards of 2 hours. They're like, why they are pouring water? Well, they're trying to, if generally what happens is one cell is defective, that goes boom, goes outside of battery management's ability to control it, but it creates enough heat that it overheats other cells that are around. Those catch on fire. Those reach overpressure, they catch on fire, and then it's a cascade failure. To dump water into it, that's all they're hoping is just like only one battery box catches on fire, other remains cool enough using water, and it could take 2 hours. So doing that inside a tunnel where you will not have access to fire brigade, it may collapse the tunnel, because again, be mindful, these things will burn underwater. So fundamentally, you do not want that dangerous system. The only way I could even conceive it is like if your locomotive has a cage, not cage, like a boom box, where you like put all these battery, you detonate it, and the cage is like, I got this, like bomb squad kind of thing. It's like, I got this. Box is like, I will not have heat to dump outside, I will not go boom, I'll handle it, only then it's safe. But generally it's cheaper to just use lithium titanate cells. It will add lot of weight because again, energy density of these cells are lower, that's why we don't use it. But again, weight is desirable, especially in locomotive design. To give you a context, when we are talking about electric locomotives, we have to put ballast weight because they are lighter compared to diesel locomotives. So we have to put ballast weight. You want weight on your wheels, otherwise it will slip. So added weight, good. How are you going to drive that puppy? Well, you're going to have 2 EV motors, one on front, one on back. They're running on differentials, simple thing, nothing fancy. But because it's a small thing, we have to add linear induction motors. Now, what is that puppy? This puppy is basically, it uses a reaction rail in the center and it magnetically climbs on it. Now, why the heck you want it? Ideally, you don't. Ideally, if your track is absolutely level, you don't have to worry about it. But it won't be. And many times metro cost comes from the fact that they have to make sure everything, like every station, let's say from underground to overground, takes time. They have to have very slow. Now, if you are in a scenario, let's say some cities, they're like, dude, we do not have land for it. They will use this linear induction motor technology. This allows them to have very steep climb because from a magnet point of view, it's not relying on the wheels. It's relying on this system, reaction rail. It's like climbing on it. It's almost like cog rail without physical contact. Now, why don't you just want to use cog rail? Cog rails wear down way too quickly, and physical contact with open contacts, as in like it's not sealed, it's open, lot of grease, lot of grime, it's a maintenance nightmare. You do not want that. So we have to use this. It has been used. Again, please do tell me down below how many things you have seen. There is a very good chance you may be one near you. We use this. Now, okay, if these are amazing, it does allow you to have very high slopes. Why don't every system use this? Well, they are inefficient. Why? Inherently they are induction motor, but problem is the gap between the stator part and the rotor part, or here the reaction part and the actor part, the gap is too high. Basically, if you have induction motor and you're like 1 millimeter, it's like awesome love, they're making good love. If you stretch it out to 5 millimeter, not that good. Stretch it out to 5 centimeter, really not good. That's why it's like, it will only be there, like the primary drive will always happen from the electric motor, the most efficient system, and linear induction would be there if train starts to slip. And if you have noticed any locomotive, you must have noticed there is always a sandbox for that. This solves that issue. And again, these are not energized. There is nothing electricity. It's inherently a passive structure. So cost per kilometer also does not go up. It's like, yeah, it does add little bit of cost, but if you are designing it properly, it's just like, yeah, it's just an extra metal strip. Not strip, it's a bit thick, generally 5 millimeters, but you get the point. That metal strip, it will allow you to handle slopes, like you can go very quickly, very up without any issue. And the only reason why I'm going with battery system, you can have hot swaps of the battery, not hot swap, I think like swappable batteries. And this is a swappable battery system used for Chinese trucks. And you can see that this will have enough capacity that you can pull battery locomotives. These locomotives are used in mining industry. It's a common technology. And you can have like that cell in this sort of design with swappable battery. So at the end of it, you do not have to worry about charging it. You just plonk it out, put a new one in. And because it's a locomotive, it's a fixed thing. Like we are so good with locomotive systems that, have you ever noticed how the heck metro stops exactly where the door is? Like think of it this way, like it's a metal thing, moving on metal things, running on different temperature, and it could have different load every time. There could be different people weight. Sometimes it could be empty, sometimes it always stops exactly where it needs to. We're good. So that's why doing this would be easy. It's like walk in the park, and it can be done in 1 minute, inside a minute. So it won't be like, oh, battery is charging. No, you pull it out, you charge it safely. And again, if you find any cell that are out of balance, you can repair it also. It does not have to be integrated in chassis. This way you can have locomotive, 2 drive motors and 1 linear just for that extra grip. It will only come on when it's starting to detect slip or is like, the slope is coming, so it will electrically trigger. And the benefit of doing this approach, your tunnels are safe, meaning you can just walk in the tunnel. For maintenance, for upgrades, things of that nature is just safe. You don't think about it, it's just like, I'm walking on a tunnel. It also works in emergency case. Let's say something bad happened in the station or in tunnel, people can walk out of it without any issue. You do not have to worry about like, dude, there is 750 volt DC or 1500 volt DC, or in case of India, 25 kV above. It's like, you don't have to worry about that. It's just like, walk out. Track is completely passively safe. And that also reduces your red tape issue. So that's why we have to go to locomotive. Then we come to the coach aspect. It's like, okay, locomotive has to pull something. So what about coaches? Now here's you have to balance 2 things. First, if you make smaller coaches, basically like a car cabin, it will be very agile because tunnel was inherently designed, but it would be inefficient. If you make them bigger, it will be more efficient, but it will have to be balanced. Basically, you cannot make them very tall. People like to make tall tracks, coaches as in, but it does come with consequences where it's like, turning radius becomes an issue. Sometimes you will literally see the bogies, like in especially some European trams, you will notice that bogies are literally moving out of the chassis. It's like, why the heck that's something? Bogies are not moving out of the bogies, are following the tracks, but coaches are so long that it's like outside is like, okay, doing that. So these 2 things have to be balanced. It's up to you. Which design? Well, this sort of pod design has to be used with sliding doors. So you do not have like door opening like that. That's just stupid. That will take too much surface area. You don't have the sliding doors, super efficient, elegant, does work. It's a known system. How many seats? 4 is the bare minimum, and again, not desirable. 4 for system. You have to have pull way too many coaches to justify it. I would say 8. Basically, you can have 2. That is the longest. It will be like a bit longer than Range Rover. Now, all of these things have to be very dumb, simple with central air conditioner. That's the tricky part, central air conditioner. Dumb, so the cost is low. Simple, as in like it will only have braking system and a trigger mechanism that tells the basically every coach will have an accelerometer, basics, microchip. And the reason for that is like that's how we slow down basically long freight cars. Freight car detects is like, okay, if I have to apply the brake, the person engages the brake, the last car triggers the brake first, then it's like starts to slow down, then the second one, then the third one, then it's like crawls up, so you do not have bam. That allows them like things to last much longer. So you do need some intelligence, but these are like one microcontroller, like one Arduino kind of system. So dumb, simple, central air condition. And it would be amazing if everything that you built can be fit inside a standard shipping container. While the tunnel Elon Musk is built, the tunnel boring machine that he's fine-tuning, so to say, is designed to be big enough where it can carry this. Generally, it would be much better idea to fit your carriage inside it. The reason for that is Indian government spent boatload of money moving these things around. And you can find the same thing even in Germany, in UK, everywhere. Moving these things are an issue. You may not have the factory, oh, I'm using here is factories here. So that is a very extensive cost. But if you can make sure everything is packed inside it, and be mindful, I'm pretty sure there are more than big enough cars that you will feel comfortable inside and be like, you know what, this is comfortable, this is good enough. Especially with 3 people, like 1, 2, 3, and does not have to worry about engines or giant battery banks. You have more than enough space. 3 people, front and back. So that gives you 6 people, or you can have double row with enough gapping in between, so a wheelchair user can at least come by, or may have a dedicated row, so where it's like front one does not have the center system. So if any wheelchair users, it's like at the beginning of the basically platform, just scroll right there. If it can fit inside the container, traveling, transportation, maintenance, repair, all of these price go exponentially down. That's another thing nobody thinks about. It's like, how the heck you gonna transport these things for maintenance, for repair? And if you looked at any national metro system, you must have noticed they build the track and then they figure out where to put the depot, so to say. And depots are huge, enormous structure. Because again, train are not something like, lol, I'm gonna do Tokyo drift. It's like, bro, curve, take your time. This, put it into a kind of a lift, I'm out. So coaches have to fit inside that. That's the only way you can keep the cost so low that it's like, yeah, it's doable. Now, what about the station? Now, this station idea is really good idea. The fact that nobody has what we call Death Valley, a safe tram station. That's what people want. Tram stations are like this, where you just walk. You do not think about it. Like, think about metro station, like be it Delhi, be it Kolkata, be it anywhere. You have 2 giant holes on the ground. You do not want to fall in them. If they have third rail system, you are serious danger. And not to mention, children do fall on it and accidents do happen. This sort of system where you have everything is level grade is desirable. It's just like, I walk. There's nothing more than that. I just walk. There's nothing to it. It reduces your safety cost, reduces your inspection cost, everything goes down. It's almost like a tram, like exactly like this. You don't think too much about it. It's just a tram station. no death valley, no high voltage power line either on top or on bottom. That's awesome. And level boarding for both sides. I have noticed many times because of metro size, it's not viable to have, and not to mention because of the death valley, it's not actually viable to have trains opening on both sides. Even though they have doors, it's not viable. But here you can have that, like literally doors will open on the both side, people will walk out. When the train leaves, they can intermingle because again, there is no death valley. They do not have to go down or go on accelerators. They are like just everything is in the center, level crossing. This is the easiest way to reduce cost of the station. And end stops will have basically everywhere you want to have that quote unquote repair depots and all that jazz. It will have a container path. What does that mean? Basically, you will figure out how the heck you have a container carrying truck and a container in the bottom to top. You will figure all those parts. Basically, you build a container path. It's like, okay, let's say this bogie needs to go on repair. Okay, bring the bogie, put it in a container, put it up through an elevator, then put it dump it on a truck, go away. You have to do all those sort of things. Again, there are tools specifically built for shipping industry, with military industry also, that they have that part sorted. And that's the easiest way to keep the cost down so low that this imagination of a station can be done. Now, if you do all these things right, how much capacity can you actually expect? Let's say this capacity is 1x, metro capacity is 1000x. Where this will be? At best 10 to 100. Yeah, that's the another aspect of it. There is a reason we use giant metal tubes. We have to, there is no other way. And many times people have the very bad image of metros. Now, the primary reason for that is twofold. First, basically management. That will destroy any project, does not matter what. Many metros are mismanaged. That's the first thing. Second, when metro initially starts, every city, be it Delhi, be it Bangalore, be it Kolkata, be it Tokyo, initially it always have very few ridership. Then slowly people start to use it. And it's like, okay, then it creates a vacuum. Meaning roads are free, people are moving efficiently. That creates a chain reaction. That chain reaction triggers basically buildings, offices near metro stations. Now there are far more people coming in. Basically, this system works so efficiently, it creates a vacuum that more people comes from rural area into the city, and voila, you're back to square one. Now people are like, oh, metros are so overfull. It's working. If it's physically moving million plus people per month, fundamentally it's working. It's just that the system was designed for million people. The moment it started to move million people, we were like, there is so much potential, so much growth space. And then more people came in, and it's like metros are like, bro, I was designed for 1 million, now you want me to move 2 million people. It reaches that point. And again, I get it, like it's hard for psychology to understand, human psychology to understand that. It's like why you always add a lane in road, and then it's like more traffic jam. Only for first few months it's like, everything is awesome. Then it's like, why more traffic jam? People came in to fill in the void. This happens with that. So this system would be idiotically expensively, God tier level dangerous. And what I suggest would be just like a bus network in a tunnel that's not as expensive as metro. Be mindful, tunnels are expensive in terms of remove the bureaucracy, remove the red tape. They are directly exponential cost with their diameter. The smaller the diameter, the lower the cost it becomes, flat out. So there is some way of doing it. Will it have true capacity to justify the cost? Las Vegas, again, they are losing money. If you have ever wondered why the heck worlds have, debt, basically there is $22 trillion debt of USA, where the heck that debt is? These sort of thing. Like India built Hyperloop project that costed hundreds of crore. That money went poof. Now that's a debt. Like India tried to build Ahmedabad bullet train network. Again, it took a giant debt out of Japan. And again, we are working on it, but it's very behind schedule. Again, more debt. That's how national debts are done. It's always stupid projects. So that's why I suggest all these steps, look into it and tell me what you think, how we can optimize more. So because I do wanted to experiment a bit more, like what if you have bad ideas? Because we humans are imperfect. What can we do? Like we have this bad idea, let's fix it. Let's make it more elegant. Let's make it practical. So this was my approach, my mind power putting into this. If you have any other ideas, I would love to interact with it in the comments. Please let them down below. So this was one of my experimental videos. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.